let's have a deep insights, or let's have a deep dive on main arguments which has been provided by Alfred Wagner regarding his plate tectonics theory. Now, Wagner, in his opinion, he postulated that continents which we used to see nowadays, they were actually the part of a one landmass. Here you can see in these two images that we have a one landmass. Here we have a one landmass, and especially in this image, here have a one landmass like this. This is what the one landmass. Here we have a one land. So this landmass means the all the continents which we used to see nowadays, all of these continents were together. They were joined together, and that grand landmass was given a name, that is. So all the continents which we used to see nowadays, they are actually the part of that erstwhile Pangea. When it was somewhere during the Carboniferous period, somewhere around 250 million years ago, this development was actually started, and then the distribution of continents which we used to see nowadays actually the result of this kind of drift. Meaning of drift is what? Meaning of drift is there is a directionless motion of these land masses. There is no specific direction in which these land masses are actually. So when we have a directionless movement, that is being termed as drift. Moving ahead. So Wagner cited that the Pangea was there, and this Pangea was there somewhere around 225 to 200 million years ago, and that was during the late Paleozoic and Mesozoic period. And here we have a Carboniferous time period, you can say. So during the Carboniferous period, all the landmass were connected, and the name which was given to those landmass, Pangea. So Pangea was actually surrounded by a one vast ocean, one vast water body, and that water body was given a name as Panthalassa. A vast water body was there, one name as Panthalassa. Later, this Pangea drifted, and yes, there is a horizontal motion with regard to these land masses. So we have a one landmass like Pangea, and then it was splitted into the major, let's say, small fragments, small land masses. Here you can see in these. So Pangea further split, and when Pangea further split, it led to the two major land masses. So one landmass was there. From that one landmass, two landmass were actually appeared. So these two landmass which were actually appeared, they are being given a name of Laurasia and Gondwana land. Here you can see we have this entire landmass, or one landmass, a supercontinent you can say, and this supercontinent was given a name as Pangea, and this Pangea was splitted, and it was splitted somewhere around Triassic period or Triassic time period. We have a clarity about these kind of a Carboniferous, Permian, Triassic. Whenever we're going to see about the geological times, see about this geological times after the completion of all of these lectures. So at last we will have a clarity about the geological. So here this Pangea is splitted into two, and we have this as a result of this split. As a result of this split, we have a Laurasia and we have a Gondwana. And yes, the part of ocean which was sandwiched between the Laurasia and Gondwana land, that was actually being known as Tethys Sea. Here we have a Panthalassa and we have a Tethys Sea. So Laurasia, you can see here. So Laurasia, which was actually the North block, this was actually comprised of North America, Europe, and Asia. And if you see the Gondwana land, which was basically the part of Southern bloc, it was actually comprising the South America, Africa, Antarctica, India, Australia, Madagascar as well. Falkland Island was also here when it comes to the southern bloc. So here we have a northern bloc and we have a that further split was there, and as a result of this further split, we have a modern day distribution of continents. So when these land masses further splitted, here you can see in Permian period somewhere 250 million years ago. Now you are looking at the different range of years, so need not to worry. In the different sources, the age is actually different. Okay, so you can remember from 200 to 225 million years ago. That will be one of the most credible time period regarding the. So somewhere around Permian period, like it was somewhere around 5 million, we have a Pangea. Then during the Triassic period, around 200 million years ago, Laurasia and Gondwana land were split. Then during the Jurassic period, around 145 million years ago, we had some sort of the continents are about to see the modern appearance. Then we have a Cretaceous period. During the Cretaceous period, around 65 million years ago, we had a distribution of continents out we are about to see. And yes, lastly, we have a present day. So it has been deciphered based on this pattern that continents were actually united. They split it into the two. Among these two, we have a further split. Then among the split, we have a further split which led to the land masses, major land masses and minor land masses, and then ultimately we have a distribution of continents in nowadays. And that's how the modern continents are being appeared on the earth.